You're going to log into the tool by using the Lab Access Login system. Click Login, then type in your username and password. Right now, we're going to log in to the Fiji ALD system. Click on it, and then press Activate. Once you've logged in, you have to follow the steps that are listed on the machine. The next step is to vent the load lock, which is located here. For that, we go to the ALD software and we go to the Vacuum Systems tab, and then we go ahead and click Load Lock Vent. Then you wait for the system to vent it out, which takes approximately 2 minutes. Once it is vented, we click OK. Once you've waited a couple of minutes and the load lock is vented, and you've clicked OK, we go to load the sample. Open the load lock, and then load the sample onto this chuck. Put it somewhere in the middle. For this video, we're using a small sample, but you may use up to a 6-inch wafer. Once you've loaded your sample, close the load lock and go back to the software. Now, we need to pump out the load lock. We're going to go to the Systems tab and press Transfer Sample. This takes another couple of minutes. Once the load lock is pumped out, a message will pop up saying please load and unload the sample. After the load lock was pumped out, there's a valve between the main chamber and the load lock chamber that was opened. Next, we'll use the transfer rod and push the chuck inside and release it, and then get the transfer rod back out. We align the arrow on the transfer rod with the mark which signifies the loading position, and we push in the transfer rod gently. When it's all the way in, we'll rotate it about 60 degrees toward the wall. Then you can slowly take it out again. By doing this, we've loaded the chuck into the main ALD chamber. Once you've loaded the chuck, you can see that it is no longer attached to the transfer rod. Now you can press OK on the computer. This will close the valve between the main chamber and the load lock chamber. Now, for the next couple of minutes, we'll show what the computer screen looks like during venting, loading the sample, and transferring the sample into the main chamber. Click the LL Vent tab. We've already shown that when this screen pops up, we'll wait for 2 to 3 minutes and then check if the load lock chamber door has been vented. Once it is vented, press OK. Place the sample on the chuck and then transfer the sample into the main chamber. Press Transfer Sample and wait for the screen to pop up. Once the dialog, "Please load and unload the sample," comes up, do the loading process that's been shown before. After the sample is loaded to the main chamber and the load lock arm is back to its initial position shown in the video earlier, press OK. Now the gate valve between the main chamber and the load lock chamber is closed. Now we are ready for the deposition process. Go to the Process tab and set the argon gas and plasma flow. Now, we will show how to set the argon gas flow by adjusting the APC set point and barometron reading. To open the isolation valve, click the Isolation Valve tab. Now, please observe the computer screen carefully. To open the gas flow, click on the isolation valve, which will turn green. The APC set point is now 26, and the barometron reading is 456 millitorrs. Change it to 24 and let the reading settle down. Now, the reading is 118 millitorrs. Change it to 16, and the reading is 178. We need to decrease the APC number to increase the barometron reading to get the required flow of the gas. Now, make it 12 and the reading will be 230. The required barometron reading is in between 200 millitorrs and 250 millitorrs. At this point, the APC set point is 12 for the required gas flow that we need to update in the recipe. Press the isolation valve to close the valve. Go to the Process tab and check the temperature of heaters 12, 13, 14, and 15. Heater 15 is for the chuck heater. These are the temperatures at which the deposition will be performed. Right now, the temperature is set at 200°C. If you want to deposit at a higher or lower temperature than 200°C, please increase or decrease the temperature after logging into the tool to save the usage time within your reserved time. The recipe does also have a provision to set up the temperature of the heaters as shown in the recipe, but it takes a significant time to get a stabilized desired heater temperature. Right now, the recipe shows all 4 heaters at 200°C, so we will keep it at 200°C. We will now show the computer screen for setting the heaters. This is the precursor delivery and the ALD valve temperature, which needs to be set at 150 C. Users are not allowed to change it. The precursor temperature can be changed where the cursor is moving around. The red and blue boxes show the current temperature of the precursor, blue boxes show the room temperature, and the red boxes show the heated precursors. For this recipe, we will use aluminum, which works at room temperature. The first one, H2O, works at room temperature, and the second one is aluminum, which works at room temperature too. The third one was silicon, but at this point it is changed to platinum, which works at 80 C and is kept at 80 C. Hafnium and titanium work at 75 C, but are kept at 50 C when not in use. To change the temperature of the precursor, write the value of the required temperature in the white boxes on top of the red or blue boxes. Right now, you are at the Process tab. Get the cursor anywhere on top of the recipe and right-click the mouse, which makes the menu pop up. Select Load Recipe and choose the recipe file you want to use. Update the APC set point to 12 as we have mentioned earlier. Also, check if the heater temperatures are set at the desired points. Check the cursor temperature as well. We are almost ready to start the recipe. We have already shown how to open the precursor valve manually. Please make sure that the precursor valve is open manually before you start the recipe. Save the recipe file after changing the APC set point by right-clicking anywhere on the recipe. We're going to open the valve for the aluminum precursor because we're doing an aluminum oxide deposition. In here, we have all the different kinds of precursors that are loaded onto the system. Here in a row, we have the precursors for aluminum, platinum, hafnium, and titanium. This is also what's shown in the software. Since we're doing aluminum oxide, we open the aluminum precursor. The platinum, hafnium, and titanium precursors have heating pads because they're kept and ran at a high temperature. There is another precursor for water, which is injected into the system. Start the recipe by pressing the Start button. Are you sure you want to start a run? Will pop up. Say yes. Please see the computer screen for the operations. At the top right of the screen in the black area, the information is displayed. At the bottom left, it shows the time and how many cycles are left. Please follow lines 18 through 20 in the recipe. Line 22 shows the number of cycles. In this case, it is showing 720. That means the recipe will stop automatically after 720 cycles. Lines 18 and 20 show the precursor number. In this case, it is aluminum, number 2, and the water, number 1. For platinum, it's number 3. For hafnium, it's 4. And for titanium, it's 5. If you're using an existing recipe, please remember these numbers and write or check your recipe accordingly. The graph shows the pressure by time plot. Please check the peak size for the corresponding pulses. The plot is adjusted for a 1-minute range. If you do not see the pulses, please contact MRC technicians and write an email to Murtec. We will not run all 720 cycles at this point, so we will abort the process by pressing the abort button, red. You may also abort the process anytime if anything goes wrong. Now, make sure to close the cursor valve manually. The video will show how to close the valve. We're going to close the aluminum precursor. Reach in and rotate the valve clockwise to do so. Then, when you're done, close the door. Go to the Vacuum System tab. Now the main chamber and the load lock chamber are at similar pressures, so we will transfer the sample from the main chamber to the load lock chamber. Press Transfer Sample and wait for the dialog, please load and unload the sample. Unload the sample using the load lock. To unload the sample, we have to move the transfer rod inside. We make sure the arrow on the transfer rod is once again aligned with the preset mark on the end. Then, we slowly take the transfer rod inside. Rotate the rod 30 degrees toward you and push very gently in so it's flush with the metal. Then, rotate it back 60 degrees toward the wall, and then you can pull it back out. The sample holder is back to the transfer chamber. Please notice the rotation of the load lock rod during the unloading process one more time. Once the transfer rod is back to the initial position, press OK. Now the valve between the main chamber and the load lock chamber is closed and we are safe to take out our sample from the load lock chamber. To do that, press LL Vent. Check the load lock door and if it is open, press OK. Take out your sample, close the door. Now we have to vacuum the load lock chamber. Unlock the valve by pressing the red button at the bottom right of the vacuum system screen. Start the LL Rough by clicking the button. Wait for 3 minutes and stop the pump by pressing the LL Rough. Now lock the valve by pressing Lock and Unlock Valve at the bottom right. Go to the Process tab and set the argon carrier and argon plasma at 10 SCCM. Also please check all the heaters. ALD valve 150C, precursor delivery 150C, heaters 12, 13, 14, and 15 200C, precursor platinum 80, hafnium 50, titanium 50. Log out and report to Murtec if you find any problem with the tool. Thanks for listening. Enjoy your ALD learning journey.